15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello and welcome. Thank you for joining us on this edition of the Space Nuts podcast, episode 212, all about astronomy and space science. My name is Andrew Dunkley, your host, and with me again is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Good day, Andrew. How are you?
I am well, sir. How are you?
I'm good, thanks. I nearly said good morning, which might not be appropriate sometimes that people are listening to this podcast. So anyway,
that's the thing about podcasting. People could be listening at any time on any day. So you've got to be a bit generic about your hellos.
Yeah.
Can prove
a generic hello from me.
Yes, fraught with danger, being specific.
Yeah,
but we'll manage. I'm sure we'll manage. Now, before we get into these topics, today's topics, Fred, we do want to mention that we've received a raft of questions, text and audio, and we are going to we haven't done this for a long time. We are going to in the very near future do an entire episode dedicated to questions. So if you've got a question you want to throw at us in the next week or two, yes, please send it through. And we'll try and add it to the mix. But we're thinking episode 215 will be all questions, all audience questions, your chance to unravel the mysteries of the universe courtesy of Fred. Now, today we're going to talk about a launch that happened the other day. I actually watched this live, although I must laugh a little at the network that showed it because the commentators basically didn't know what they were looking at. Because they were just in a TV studio, and the host said to the supposed expert, "What's happening?" He said, "I don't know," and they were talking about the water spraying underneath the burners, which is obviously to douse the flames and reduce the amount of refuse flying into the air, all that sort of thing, and they had no idea what was going on. So, and as soon as the thing got off the ground, they cut to a promo, so we never actually got to. Never got to see the thing get up in the air. But anyway,
on channel, Andrew.
I clearly was.
Yeah,
but this was a space launch by the United Arab Emirates, not usually a country you'd associate with space exploration, but they're off to Mars. We'll talk about that. We're also going to look at Venus again, but for a very, very different reason this time. It's starting to be thought that it might still be volcanically active. Can you imagine that? We'll also be answering questions. We've got one from Bobby Jim Ascot about a Terrascope, and Peter from Sunderland is asking a question of, if Einstein was alive today. We'll get to what he wants to talk about a little later in the program today. But first, Fred, the UAE, the United Arab Emirates, a country I have had the pleasure of visiting. What an amazing place. It's sort of like I don't know, Las Vegas without casinos. It would be the way I describe it. Very elaborate, very ornate, just no slot machines. But fascinating place. But they've just launched a mission to Mars.
Exactly. And this is the first, Andrew, of probably 3 Mars launches this month because we're in Mars season. We're in that period in the orbital dance between Mars and the Earth where you've got the shortest travel time between the two. So launches this month and next month they've got the most energy efficient route to the planet Mars. Hope has been first off the block. The UAE's orbital spacecraft. We expect the next one to be a Chinese spacecraft, and the one after that to be NASA's Perseverance, the rover that's going to look for signs of life on Mars. So hopefully you and I will talk about all of those down the track. But for the moment, the one that is already on its way, Hope, which was launched on Monday, as you said, from the Tanegashima Space Center in Japan. I was delighted that it went to Hope went to space on board a Mitsubishi, which is what I drive. So there you are.
Oh, I used to drive a Mitsubishi. Well, they're claiming it's the Mitsubishi Heavy Industries H2A rocket, but it was in fact the Burj Khalifa.
Mine isn't the H2A rocket, but it gets me around all right, I can tell you. So yes, it's a well-proven launch vehicle, actually, the Mitsubishi H2A. I think it's got a track record of something like 40 spacecraft, 40 satellite launches. So that, of course, reveals straight away that there is a strong connection between the United Arab Emirates Space Agency and the JAXA, the Japanese Space Agency. These two organizations have worked together on this project. And actually, that's perhaps one of the characterizing features of HOPE, in that there is broad international collaboration. The University of Colorado in the USA has been responsible for some of the instruments that HOPE is carrying to Mars. Really interesting project, and with the name kind of tells it all. Amal is the Arabic word, but HOPE is a lot of it is about international collaboration. It's about inspiring people. It's about inspiring the Arab world generally, because it is the first mission to another planet from the Arab world. So a lot going for it in terms of education and STEM and all those other things in UAE. This is bound to work wonders. UAE, just by the way, is not a stranger to space travel, though, because one of their astronauts actually flew on the International Space Station last year, an Arabic astronaut, and that was very successful. I think it was a fairly short trip. But there is, it's a very active organization, the UAE Space Agency. So the launch was flawless. I know what you mean about the talking heads on the channel. There were a number of different channels that you could watch that on. One of them, everything was in Arabic, so I gave that one a miss. There was another in English, which I suspect is what you watched, but the one to watch was the one without commentary, which actually showed all the details of the launch. So we could see the rocket lifting off and on its way, almost, it was perfect conditions and a very, very fine launch. We saw all the features of a launch as the vehicle went through its maximum dynamic pressure. It formed clouds around its nose, and the boosters separating. We couldn't see the second stage separation. That was too far down range. But as far as I know, a flawless launch. And to the best of my knowledge, Andrew, to wrap this up, sorry, I've talked a lot, but to the best of my knowledge, the mission is, as we say in the game, it is nominal at the moment.
It is nominal.
Yes,
it is nominal. I do have a question about this mission.
Yeah.
What is the aim of the mission? I assume because it's called HOPE that the mission's aim is not that they hope they find Mars. I'm pretty sure they will. But why are they going there?
Yeah, that's a great question, actually. I'm really glad you asked it, because this is not just, doing the same sort of thing over again. So there is a specific scientific area of understanding that HOPE is designed to look at. And it's particularly the interaction between Mars's lower and upper atmosphere, which is a fairly poorly understood system. We know quite a lot about Mars's lower atmosphere from the rovers down there on the surface. We know quite a lot about Mars's upper atmosphere from spacecraft like MAVEN, depending on how you want to pronounce it, which is in orbit around Mars at present. But HOPE is designed specifically to look at how these two behave. It's got 3 scientific instruments on board. Basically, one is a high-resolution imager, so it will be looking at cloud formation. It will be also looking at the surface, of course, and then 2 spectrometers to look at the elements in the atmosphere, one in the ultraviolet, one in the infrared. So very specific questions that we hope will be answered by HOPE. It dovetails very nicely into the flotilla of spacecraft that have already gone to Mars in terms of its scientific mission. And just one final thing, assuming this mission is successful, it will be the fifth, will make UAE the fifth spacefaring nation to reach Mars. I'm just trying to remember what the others are. NASA, of course, Russia, India, and I think China is the other one. And UAE will be fifth.
I'm kind of glad that they're going up there to do an atmospheric analysis, because if they were going there to check out the topography, they've spent a lot of money to do something that they could do by just walking outside.
Yes, exactly. But they've also, the topography is well understood now from all these radar missions that we've had. So yeah, it's a great venture.
Indeed, and we wish them well, and can't wait to see how they how that mission goes. And once we get some feedback from whatever it is they discover, we'll let you know. The other thing, and I think I've mentioned this before, Fred, but the other thing I like so much about these kinds of missions is how it brings nations together. You did talk about the UAE and JAXA getting together, but you see collaborations between the US and China, and the US and Russia, and it sort of is a unification that occurs at this level, aside from the nastiness of politics at times. You've got at the moment the political clashes going on between the US and China, and yet they're more likely to collaborate in space than they are in the boardrooms of political at the political table. So I think astronomy and space exploration and those kinds of things are actually doing a lot more good than people give it credit for sometimes.
I agree with that, Andrew. And space, as it should do, space unifies us all, because we realise that we are, we're all travellers on a spacecraft called Earth. We've got to look after it and work together to make the world, and space too, perhaps, a better place.
Yes, and we'll all soon look more like space travellers soon when we start wearing masks.
Yeah, exactly.
You're listening to the Space Nuts podcast. Andrew Dunkley here with Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Thanks for joining us on the Space Nuts podcast, and hello to our YouTube subscribers. We're building up quite a number of YouTube followers, and that's resulting in a lot of downloads. Now, apparently, we're averaging about 3,000 downloads a month on YouTube, which is fantastic. But, as always, our producer has come to me and said, we need 4,000. I said, why? He said, because. So we need to get another 1,000 downloads a month on YouTube. But, I'll leave the science up to him. But if you are a YouTube user or subscriber and you'd like to follow us on our YouTube channel, you can do that at youtube.com/c/spacenuts, youtube.com/c/spacenuts. And that's just one of the many platforms you'll find us on. Now, Fred, let's continue our foray into space. And we're headed not to Mars this time, but we're back to Venus, which we talked about last week with that upcoming mission, which is going to do some deep penetration radar imaging of the hottest planet, one of the hottest planets that we know of in our vicinity. And now we're starting to think that the volcanoes, or some of the volcanoes on Venus, might still have a little bit of pep in them. Is that the case?
Indeed, that's right. So this is quite exciting research. It's very good that we're seeing this sort of thing being published, in advance of possible upcoming Venus missions, because it sets the scene in a way. It sets the scene as to the questions that we might ask on a future Venus mission. So, what this is about is essentially a reanalysis, Andrew, of some of the radar imagery that came back from Venus back in the 1990s, actually. This is from the Magellan spacecraft. This is long before Space Nuts podcast, so you and I didn't particularly talk about this, but Magellan was equipped with radar and basically mapped the surface of Venus for the first time, because, of course, Venus has this thick, poisonous atmosphere that we can't penetrate. At least under normal circumstances, certainly with visible light, you do get nearer the bottom with infrared, but even then it's not giving us any idea of what the surface is like. Radar is the only way to do it. So a group of scientists in the United States have trawled through the Magellan data, and what they're looking for specifically is some features which are they're ring-like structures on the surface of Venus. They're called coronae, and coronae being the plural of corona, which of course means crown. And these days our minds immediately leap to the coronavirus when we think of that word, but this is nothing to do with the virus. This is just the shape of these structures. They're crown-like structures. And there's some understanding already of how these things are formed, because they're thought to be caused by hotspots underneath the surface of Venus. So it's a kind of upwelling of hot rock there. There's Gregory Peck, by the way, the rooster, just joining in there. I don't know whether you caught him.
Is that from the vets next door? Oh, no, that's yours.
It's Marnie's, yeah, that's right. Never mind.
Gregory Peck.
Gregory Peck, yeah. So you got. Thank you, Gregory. This is just outside the door. Sorry about that. Wanders around.
Oh dear.
Yeah, we've got these hot spots underneath the surface of Venus, and so you get upwelling. That's the technical term. Stuff coming up through the mantle of Venus, and penetrating through the crust and giving you a volcano. Now, we know that Venus does not have plate tectonics. That seems to be an established fact among Venus watchers. And that means that a bit like the phenomenon on Mars, where you've got these huge volcanoes because the hot spots penetrated through the crust and just kept on going through the same hole in the crust because nothing's moving. There's no plate tectonics. So you get very large volcanoes. Now, I think that is also true on Venus, except that Venus is far more volcanically active than Mars ever was. It has the most number of volcanoes of any body in the solar system. So what they've done is they've looked at these corona structures. In fact, I think 133 of them have been examined in detail. And essentially, the details of the shape of these, and I should explain that it's kind of almost like a ring formed with a trench-like structure around this volcanic plateau. Some of them are thousands of kilometers across. The bigger one, they're typically 100 kilometers or so. But they also have these sort of radial fault lines in them as well. So there are faults occurring too. And it's by looking at those structures that you can get an idea as to how long ago the activity ceased. And thank you, Gregory. One of the work, basically one of the authors of this work, somebody called Anna Gülke, has said, our work shows that some of the interior heat is still able to reach the surface even today. Venus is clearly not so geologically dead or dormant as previously thought. Sorry about that.
You're having a fun night, a fun day today.
It is. The last thing I was going to do before we went on air was put my phone on silent. So anyway, and it's from somebody who should know better because she knows I'm doing the podcast.
Oh dear. Hello, Marnie. No, I don't.
All right. Yeah, there you are. Everybody's joining in now. So
everyone's in.
So the evidence seems to be that of the 133 coronae that have been investigated, 37 seem to have been active, and this is the bottom line, within the last 2 to 3 million years. And of course, that's very much the recent past in geological terms. It's probably speaks volumes for the idea that Venus actually is volcanically active today. And what a thing, that you can now sort of imagine beneath those layers of clouds. You can imagine smoking volcanoes doing their thing.
Yes, indeed.
Amazing stuff.
Yeah. And I find it fantastic that we can reanalyze data from old missions and extrapolate more information from it. Like because we've got the tools now that we may not have had 30 years ago or whatever, we can reanalyze data from these old missions and get even more value out of them. I think that is just an amazing step forward for astronomy as well.
Yeah, that's right. With modern tools, modern software, the kind of analysis tools that we have these days, which certainly weren't around in the 1990s when Magellan was doing its thing. So really extraordinary stuff, Andrew, and I think really interesting news as well, that we have yet one more volcanically active body in the solar system, along with the Earth and Jupiter's moon Io.
And Titan too, isn't Titan active?
It probably is. Yeah, these are cryovolcanoes. That's right. Maybe even Pluto as well.
Yeah. Wow. Fantastic. Are they able to be specific about where they think they are, or they just think they are?
No. These are well identified sites on the planet's surface. Apparently, they form a sort of ring-like structure. All around,
funny that,
all around the planet's southern hemisphere. So what you've got is this ring of these things in the planet's southern hemisphere. Apparently, the biggest is a corona called Artemis, which is 2,100 kilometers in diameter. It's colossal.
That is amazing. Yeah, not as big as Olympus Mons, I'm gathering.
Olympus Mons actually is yes, it's a bit smaller than that. I think is Olympus Mons. That's a good point.
Oh, okay. Ooh, so it may no longer be the biggest,
but Olympus
mountain in the solar system
is the highest.
Highest, right. Gotcha. Okay. Well, we will watch with interest because there may be more to discover, and certainly it will be helpful to know about these things, as you said, with future missions to Venus, so that they can maybe take a look, or if they're going to land something on the planet, which is always a haphazard thing to do, they know where not to go. But it looks like Venus has got a lot more to tell us than we thought 20, 30 years ago. You're listening to Space Nuts. We'll be back in a moment once Fred has gone and prepared a chicken for dinner.
3, 2, 1.
Space Nuts.
Well, I can tell you I'm not really sure of the fate of Gregory Peck, but I suspect he's still at the door and still pecking, because that's what he does when you try and interfere with his daily protocol, Fred tells me. By the way, if you're a social media person, don't forget to join the Space Nuts podcast group on Facebook, where everybody who listens to Space Nuts can get together and chat to each other and ask each other questions and solve all the problems of the universe without us having to do it for you, which we don't tend to do anyway. There's also the Space Nuts Facebook page. You'll find us on Twitter. You'll find us on all sorts of platforms, social media platforms. So have a look for us and say hi via your favourite one. And now, Fred, it's time to answer some questions. And our first question comes from Bobby Jim Ascot. It's a very short and sweet question, but it is a really good question too. Hi, guys. Just wondering if Fred could talk about the recent idea of a Terrascope, the use of the Earth's atmosphere as a lens. And he goes on to say, magnificent.
Yeah.
Now, I believe there is some work being done in this area.
There is a paper, yes, by an author by the name of David Kipping. And that paper was published in was published in PASP, which you will recognise as being the publications of the Astronomical Society of the Pacific. It's a journal that is a distinguished journal, certainly very reputable. Often concentrates on solar system studies. So what is this about? We know that the Earth's atmosphere refracts or bends light, and that actually is because it's essentially this sphere of air which surrounds the Earth, and in many respects acts like a lens. We can see the effect of it to some extent if you watch a sunset. It's actually easier to do with a moonset or a moonrise because it's a lot easier on your eyes, and you don't have to use filters or anything. Full moon rising, let's do it that way, often looks slightly squashed top to bottom, and that is
I've noticed that when I've taken photos of full moons that it does seem to be a little bit sort of egg-shaped.
That's right. When it's very close to the horizon, and that's because of the refraction of the atmosphere. It's the atmosphere acting like a lens, squashing it down. So what you can then extend this idea to is looking at the whole Earth itself from a distance in space and imagining the thin layer of atmosphere basically behaving like a lens. So what you've got is a kind of natural telescope. And that's this paper by Kipping is about exactly that. So let me read a little bit from the abstract because that sort of explains what's going on. Distant starlight passing through the Earth's atmosphere is refracted by an angle of just over 1 degree near the surface. This focuses light onto a focal line starting at an inner boundary out to infinity, offering an opportunity for pronounced lensing. And so what the author then goes on to do is to essentially just imagine what you might learn from using the Earth's atmosphere as a lens. And he's done this actually in the wavelength range from visible light out to far infrared, what we call 30 micron light. So the bottom line, and coming right to the end of this, let me just read the last bit of the abstract. What does he say? A terrascope, the terrascope that he is proposing is calculated to produce an amplification of 45,000. That's an increase in brightness for a lensing timescale of 20 hours. I'm not quite sure what that means, because I haven't read the paper. In practice, the amplification is likely halved to avoid daylight scattering, because that's one of the problems. Of course, the atmosphere is bright when it's being illuminated by the sun. So there's only certain times you can do this. So that comes down to 22,500. And by that, so he's drawn an analog that is the equivalent to a 150-meter diameter optical telescope. Now, that's all fine and dandy, but you've got all kinds of problems to deal with if you're going to do this in practice, like arranging your detector so it's in the right place to look at the object that you're trying to see. You've got the issues of what we call deconvolving the information, because you're not getting a beautifully formed image like you would in a 150-meter optical telescope. You're getting this smeared out, blurry thing that, with some numerical analysis, might actually give you some information. But it's an interesting idea, but seems to have limited practical value. And I think there is an analogous thing that might actually be more effective, which is to use the Earth as a gravitational lens. And that is not using the atmosphere to bend the light, but using the Earth's distortion of the space around it to bend the light beam coming from a distant object. we use gravitational lenses all the time in astronomy. The Earth's gravitational bending is not large; it's small because it's a relatively small object. But if you're at a distance now, the problem is I can't remember how far away you've got to be to see the image formed by the Earth. But I've got a feeling it's about a light year. It's a long way away. But I think you actually get better results from that because you don't have to cope with things like the atmosphere being bright, and you've got effectively a bigger telescope. So that's just throwing in from a position of complete ignorance an alternative, which I think is also quite exciting, to use the Earth as a gravitational lens.
Yes, indeed. So it's good theory at the moment, but practicality is needs a bit of work.
I think that's the bottom line. Yep.
Yeah. Okay. There you go, Bobby. I hope that answers your question, and thanks for sending it in to us. Now, Fred, we have an audio question, so let's get down to it.
Hi, it's Peter. I'm from Sunderland in the UK. Just like to say, absolutely amazing show, the best podcast I listen to. Well done. I would just like to ask, if Einstein was alive today, what do you think the biggest mystery he would want to solve is? Thank you.
Okay, that was for those who are having trouble with the accent. Peter from Sunderland in the UK. Our translation software that we use when we receive an audio question actually translated what Peter said to, "Hi, I'm Peter from Cylinder in the UK, dyslexia."
Well, look,
no offense, Peter. It's just software.
Yeah, Andrew. But I have to say that software does its best, but when you get such a marvellous accent as Peter's, why, Peter, man, that's a canny accent you have there. Because I used to live not very far from where Peter is. Peter's in Sunderland, which is on Wearside in the northeast of England. I lived for several years and had a lot to do with Tyneside, which is just a bit further north, but with a very similar accent called Geordie. And it really did me good to hear Peter's question when he came on. I thought that's taking me right back to my roots, is that? So a great question.
Yes, indeed. Now, just in case people didn't quite catch what he asked, he said, if Einstein was alive today, what do you think the biggest mystery he would want to solve would be?
Yeah.
So... yeah, that's a really interesting question.
And, it's got an interesting answer too, Andrew, because my guess is that he would be fixated now on exactly the problem that occupied the last 20 or 30 years of his life, which is trying to unify relativity and quantum theory. Relativity, his own theory of the way gravity behaves, and works over very, very large scales. Quantum theory, which was a theory that emerged around about the same time as relativity, that works well on small scales but has basically little connection with relativity. The two don't seem to be compatible, and yet they both work perfectly in the areas, in the realms in which they are, which they're best suited. Why is that? Why is it likely you would still be working on that? Because it is still one of the hottest topics in modern physics. How can you reconcile the two? And the reconciliation, really, what people are looking for is a quantum theory of gravity. So gravity, one of the four fundamental forces of nature. The other three are the strong and weak nuclear forces and electromagnetism. We understand those in the quantum realm. All the particle physics experiments that are done have what we call a standard model, and we can get our heads around those four fundamental forces, and it all seems to work. But gravity has defied any kind of understanding at the quantum scale. We think there are things called gravitons, subatomic particles that carry the force of gravity, but they've neither been discovered, nor is there a theoretical framework that really gives you any idea where they are. And so at the moment, physics is looking all the time for holes both in relativity and quantum theory that might indicate that, or show us the chinks in our understanding that might show where we might go to try and further replicate what's going on here. That big question about the reconciliation of quantum theory and relativity is also the basis of trying to understand dark matter and dark energy. So all these problems are folded exactly into that. And Peter, I'm sure Einstein would still want to work on that problem if he was alive today. It's a great question, and with, I think, a really interesting answer.
Yes, indeed. And because I suppose another thing that he might want to try and do is prove himself wrong.
Yes, that's
with
right.
relativity.
That's right. Well, in a way, as soon as we start finding gaps in our understanding of relativity or quantum theory, which is how this work has got to go if you're going to advance it, then in a sense you are proving Einstein wrong. But he's been pretty damn right so far. Relativity works to within one part in, I think, 10 to the 23 or something like that. It is just astoundingly accurate. Quantum theory likewise, and yet they're not. They're not telling us the same story. They're not reconcilable.
Yeah, fascinating. All right. Thank you, Peter from Dyslexia in the UK. We appreciate the question. There probably is a place called Dyslexia, Fred, but they probably say it backwards.
Well, that's right. And our software, translation software, would probably not cope with it again either.
I very much doubt that it would, but at least it tries, just like we do. And it gives us adequate answers as well, just like we do. But appreciate your question, Peter, and Bobby. Thanks for sending those in today. And we are going to get through as many questions as possible in coming weeks. And again, urging you to use the audio option on our Space Nuts podcast website, spacenutspodcast.com. There's a little tab there called AMA, and if you click on that, you can see how it all works. It's really quite simple. Be a part of the show, basically, and if you've got a microphone plugged into whatever device you listen to us on, all you have to do is hit start recording and say, "Hi, I'm Joe Bloggs from Connecticut, and I have a question about general relativity," and go from there. What's going to happen now is we're going to get 15 questions about general relativity, I imagine. But there it is. That's how it is. Or you can do it the old-fashioned way and send it to us by letter with a stamp. Make sure you've got enough money to pay for it these days. Or you can email us or message us or whatever way works for you to send us the questions through. I do hunt for them because I know they pop up in some weird places, but most of the time I do find them and I send them all to Fred. And he goes, "Oh, well, that's rubbish. Well, that's rubbish too." And we don't do any. No, we do like your questions. And as I mentioned at the head of the program, we are going to dedicate probably episode 215 to audience questions entirely because we haven't done that for a long time and we've got a bit of catching up to do. But that doesn't mean stop sending them because we do love to hear from you. And we do love to hear your voices too. Don't we, Fred? It's always fun.
It's great. Yep. Thank you. Thank you.
All right.
Thank you to everybody.
I think. Sorry, I keep talking all over you.
It's quite all right. Finished now.
Well, you've got a damn chicken talking all over us, so I might.
Yeah, you might as well. That's right.
So anyway, we're going to wrap it up for another week. Thank you, Fred, as always. Oh, by the way, if you're a patron, whether that's through Patreon or Supercast, we've got some more bonus material coming your way very, very soon, perhaps even right now. So listen out for that. Fred, thank you, and we will catch up again real soon.
Sounds great, Andrew. Take care. Look after yourself. Watch out for those chickens.
Indeed. Professor Fred Watson, at large here on Space Nuts, along with Gregory Peck. And from me, Andrew Dunkley, farewell. We'll see you next time on another edition of the Space Nuts podcast.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
He's pretty feisty as well, is Gregory. If you go and try and chase him away, he's just as likely to take a pot shot at you with his beak. Should I just try and move him off the veranda then? See.
Oh, if you want to, yeah.
Where are you? That was a complete failure.
Oh, okay. At least you tried.
He's right outside the door. That's why he's so loud. I don't want to push him off because I don't want to hurt him, but